Adding and subtracting polynomials. A polynomial is a group of terms that are coming together to make one piece. So for example, if we're given the polynomial negative 2 plus x minus 8x squared plus 4x to the third. So this polynomial has 1, 2, 3, 4 terms. Terms are separated by addition or subtraction. So in this case, the first listed term is negative 2. The next term would be plus x, so positive x. The next term would be negative 8x squared. And the last term would be positive 4x to the third. So we have 1, 2, 3, 4 terms, so 4 pieces. We can write our polynomial in a couple different formats. If we wanted to write it in descending order of the variable x, that means we start with the highest x power and then write to the lowest x power. So here's our highest x power of x to the third. Here we have x to the second. Here we have x technically to the first. And here we would have really x to the 0 because there's no x's here at all. So to write this in descending order of the variable x, we would start with our 4x to the third. And then we have our negative 8x to the second, so minus 8x to the second, then plus x, and finally minus 2. If we're looking for the degree, we look for the highest power in the leading term. So in this case, all we have for our variables is x. So this would be a third degree because x is to the third power. If we're looking for our leading coefficient, that means that we're looking for the number that is the front of the very first term. So in this case, our leading coefficient is 4. Let's look at another one. For number 2, if we have 5x y to the second plus 3x to the second y to the fourth minus 9 minus 2x to the third. So if we're writing this in descending order of the variable x, we again start with the exponent that is the highest on our x variable. Notice we have other variables. Here we have a y to the fourth, but we weren't asked to write it in descending order of y. We were asked to write in descending order of x. So we would still start with this one. So this is a negative 2, so that whole term comes as the first term. So negative 2x to the third. Then we have x to the second in this term, so plus 3x to the second, y to the fourth. We have x to the first in this term, it's positive 5x, y to the second, and we have no x's in this term, so minus 9. If we're looking for the degree, we need to look for all of the exponents and we add them together in each term. So for example, all the exponents in this term is 3. Here we have 2 and 4. So all of the exponents total, we have an exponent value of 6 in this one. Here we would have a 1 and a 3. So we would have an exponent value of 3. So this is the degree because it is the highest exponents. So in this case, we have 2 exponents here, 4 here. So this would be a 6th degree polynomial. The leading coefficient is the coefficient of the term right here, so that would be 3. Let's look at some more examples. If we want to add these two polynomials, we need to look at the powers to make sure that we are adding the same things. So n to the second, n to the second. So that means we are looking at 5n to the second. We have plus right here, so plus 9n to the second. If we're looking at just the n's, this one doesn't have any just n's. This one has 3n right here. And then if we're looking at the constant terms, in our first one we have a minus 7, and here we have a plus 12. So that will look like negative 7 plus from right here, and then our positive 12. So when we combine all this together, 5n squared plus 9n squared. Well, 5 plus 9 gives us 14. So we're combining our like terms, 14n squared. We don't have any just n terms here, so we have 0 plus 3n. So that's just 3m. And then we have negative 7 plus 12. Negative 7 plus 12 gives us 5. Let's try again. All right, lots of fractions on this one. So let's make sure that we are considering the like terms. So here I have xy to the second. Here I have xy to the second. So these are like terms. So we'll have negative 3/5 xy to the second minus negative 1/2 xy to the second. And then we'll have right here our 5/8 and our 3/5. So that will look like 5/8 minus 3/5. So when we put all these pieces together, well, we need to work on our fraction. So negative 3/5 minus negative 1/2 is really plus 1/2. We need a common denominator. So if I multiply this one by 2, top and bottom, and I multiply this one by 5, top and bottom, then we will have 2 times 3 is 6, so negative 6/10, plus 5 times 1 is 5, so 5/10. Negative 6 plus 5 is negative 1/10. So that gives me negative 1/10 xy squared. Let's move this work out of the way so we have a little bit more space. Same thing if we're looking at our fractions here. We have 5/8 minus 3/5. So I need a common denominator. So if I multiply this one by 5 and 5, and this one by 8 and 8, 5 times 5 gives me 25. So we have 25 over 40 minus 8 times 3 is 24. 25 minus 24 is 1. So this is 1 over 40. Now let's clean all this up because we made a bit of a mess. So when we have our negative 3/5 xy to the second minus negative 1/2 xy to the second, that's going to give us negative 1/10 xy to the second. And when we have our 5/8 minus 3/5, that's going to give us 1/40. There we go. Let's try again. Sometimes you will see an addition or subtraction problem written vertically. Maybe it looks like this. You have to make sure that the exponents are lined up. Here I have the third power, here I have the third power. Those are lined up. Here I have the first power, here I have the first power. Those are lined up. Here I have no y's, here I have no y's. Those are lined up. And if that's the case, and we're looking at addition in this one, we can add straight down each column. So looking at 5 plus negative 6, that's negative 1. Looking at 8 plus 4, that's 12, and carry on your y to the first. I'm looking at negative 6 plus 9, that's 3, and carry our y to the third. Let's try a subtraction. This is a long one. All right, so we have a complicated one here. We need to solve this in two parts. It's asking us to subtract this from this. So before I can subtract this from this, I need to add these two together. So let's look at our common pieces and add these together first. So if I'm adding these together, well, here I have 2z to the second plus z to the second. So that's going to be 3z to the second. Then I have minus 3x. There are no x's in this one, so minus 3x stays. Then I have plus m, and I have minus 2m. So m plus negative 2m is minus m. That is these two pieces added together. Now the question is asking us to subtract this from this, which means I need to subtract and move this underneath. Now I need to line this up. So I have negative 4x. I would not put that here, even though it comes first. It needs to line up with the x column. So negative 4x goes right here. Keep the negative, keep the negative. It carries along. We're just taking that whole term and putting it in. Then I have plus 2z to the second. So that's going to go right here. I'm subtracting. You could put a plus right there if you wanted to remember it was positive, but remember having nothing, it also means it's positive. Here I have 3m, so plus 3m. Now we need to be very careful. We're subtracting. We have our subtraction right here in the front, but we need to remember we're subtracting when we come to each piece. So we're looking at 3z to the second minus 2z to the second. 3 minus 2 gives us 1z to the second. Now I have negative 3 minus negative 4. So that would really look like negative 3 minus negative 4, add the opposite. That's going to give us positive 1x, or just x. Then we have negative 1 minus positive 3. So that's going to look like negative 1 minus 3. Well, negative 1 minus 3 is negative 4. You have to consider this subtraction with each piece. Let's try one more. This last one is a picture. So let's draw this on. There we go. Here we have 8x plus 7, x squared plus 3, 7x plus 11, x squared plus x plus 6. There's a lot of ways you can go about this one. When it's written out like this, you could write it out in a vertical format like we did before. What I like to do is work my way around the figure and then just cross them off as I go. So for example, I know x to the second is the highest term, so I'm going to start with x to the second. I see 1x to the second right here. I see 1x to the second right here. So x to the second plus x to the second gives me 2x to the second. So I've crossed those off as I've used them. After x to the second, in descending order, would come x to the first. So let's look for those. Here I have 7x to the first. Here I have 1x to the first. Here I have 8. 7 plus 1 is 8, plus 8 is 16. And then continuing in the same format, looking at the constants. I have 3, 11, 6, and 7. So 3 plus 11 plus 6 plus 7 gives me 27. So there we go.